Welcome back. So we said, let's focus on 2D at the moment, and let's do some exercises to understand how to design something when we know how to move around the interface. So let's start. Now, this is basically the basic setup of Rhino. We already went through it. This is the top view. It's very comfortable to draw in this view because it's the easy one. So you've seen that there's this grid here, two lines, one red, one green. Well, this is actually the origin of the world. So Rhino has an infinite paper in every direction. This is where we start. If I draw a line, Rhino is asking me where this polyline will start. If I type 0, 0, here we go. My line is now starting from the center of the world, from the intersection between the x-axis and the y-axis. From here, I can tell Rhino where are the other points of my line, and through that design something. Let's start with something simple like a square. So I want to draw something like a square of 200 millimeters per side. How can I do that? Well, it's pretty easy actually. So the first point was in 0.0. The second one will be in 200, 0. Now this line is an horizontal line, 200 millimeters long. The third point of my triangle is going to be 200 in this direction and 200 in this direction. So 200, 200. While typing, you see that Rhino is snapping the informations, snapping the end point of the line to the information I'm giving. So while it was 200, 20, it was here, but it was already, vertical and straight. So it's very useful to see if I'm actually doing things the right way. Now this point is going to be 0 in x because I want it aligned, and 200 in y. So 0, 200. To close it, I can type again 0, 0, or I can just say close. This is a square of 200 millimeters per side. Rhino is also telling me that it's a closed curve. This is very useful when you laser cut something. You want it to be close, otherwise it's not cutting away anything. It's just kind of get stuck to the piece that you were cutting it from. Now this is a simple way to go, but of course it means that I know where I'm starting from and that I know every single point in my design. That could be less easy if, for instance, I'm drawing something a bit more complex than a square. So even with simple things, when I don't know exactly where I am, I don't have references of the grid and the center of the world anymore, what can I do? Well, the concept is basically the same. I just have to use relative dimensions instead of absolute one. So the relative dimensions are not referring to the center of the world, but referring to the last point you draw. So in this case, I just have to type R for relative, or at. It's the same thing, just pick up the one that is more comfortable to you. Let's say 200 millimeters as we did before. So relative 200, 0. The next line is going to be vertical from this point up. So the last point was this, not this one anymore, this. So this point is not going to be 200, 200 anymore, but it's going to be 0 in x. I don't want to move on x. And 200 in y. Relative, again, very important, 0, 200. There you go. Here you got your second point, and now we have to go back. Same concept. Last point is this. In this case, we don't move on y because it's an horizontal line. We just move on x. Because we are going backwards, so we consider this line positive. Whatever goes in this direction is negative. Relative minus 200, 0. Again, now just the last point missing. I can close the curve. I can type 0, minus 200 to get back. Or I can use the snaps. The snaps are special points. You know the concept of snaps, of course. And here you can select which one are going to be active and which one are not. Now, sometimes you need to disable everything just to be able to get very close to something without actually snapping accidentally on it. But in general, it's useful to keep it on. And as you can see, it simplifies a lot the way you design things. Now, this was a way. Is not the only kind of coordinates you can use in Rhino. The second one is called polar coordinates. So in the case of polar coordinates, I don't know exactly the second point. So I'm here, I want to draw something that it's, let's say 100 millimeters at 35 degrees from the horizontal line. So something that goes up a bit like this. Now I could do the math and figure out what's the coordinate of this point, but it really seems pointless. So I can more easily do relative, because it's still a relative dimension. 100 millimeters angle. This sign here is to say we are not talking about x and y anymore. We are talking about length and angle. And we said 35 degrees, sorry. And that's gonna be. So this line, the second point of this line, will be tricky to find and maybe not super precise because of the math that is required. This way is much easier. Now, just to clarify the concept, let's say this is the origin of our line. Horizontal on the right is 0 degrees. So this is considered to be 0. Give me just a second. Okay, so in this direction, horizontal in this direction, that's considered to be 0 degrees. Now, if we consider all the possible direction, or at least, let's say, some, what are the angles here? Well, as we said, this is 0 degrees. So on the right, horizontal is 0. It's our reference. This going up, so counterclockwise, this is increasing. So that means that 45 degrees is actually here. Now, what about this? Well, when you go down, so clockwise, you decrease the amount of degrees. So basically, that point could be described as minus 45. This means, let's zoom out a bit. This means 90 degrees is actually here, and minus 90 is actually here. Now, where do we stop? Nowhere, actually. So I can go all the way around and get minus 180 here and minus 270 here. The same way I can go in the other direction, so get plus 180 degrees here and 270 degrees here. So just to keep it in mind, this point can be described, this direction more than point, can be described both as a negative angle of 90 degrees or a positive angle of 270. Now this could look a bit abstract, but let's keep it in mind for a second. So if we want to draw the same square we did before, but using this time polar coordinates, how do we do that? Well, we start from a point, relative with the r or relative with the at, as we said before, is the same. 200, 0, up, relative 0, 200, relative minus 200, 0, and close. And this is the way we did it before. We did it this way, but if you think about it, it's like saying 200 in this direction, and then 200 in this direction, and then 200 in this direction, and then 200 in this direction. If we translate that, keeping an eye on this, it means 200 in 0 direction, and then 200 in 90, in 90 degrees direction, and then minus 200 in 0 direction, or 200 in 180 degrees direction. So the last two were exactly the same thing. In one case, I described it a positive length in this direction, 180. In the previous case, I described it a negative length in 0 angle direction. So I know it's tricky at the beginning, it sounds a bit weird and a bit of a nonsense, or why should I learn how to use this? But this is actually super useful. So what if we want to have a circle here in a specific position that could be 10 millimeters and 10 millimeters, a circle of 4 millimeters? Well, I can draw a temporary square, for instance, relative 10, 10, and have the center point for a circle, let's say of 5 millimeters in diameter. Now when I remove this, I know that the position of this circle is exactly where I want it to be. It's easier done than said, so I suggest you to try to do some exercises, and I prepared some for you that you should actually already have in the previous presentation. So we'll go through the first one together. Have a look at the video, of course, have an idea on how to do things, but then try it yourself. This is going to be very important for you to get confident. When we get to the laser cutter exercise, you'll see how things could be done and what's your way to work around the situation. So you will develop your own method. To us, it's totally fine. Okay, so let's take the first exercise. If we go back to, If we go back to our introduction, I'm sorry about this small gap in the presentation. So if you scroll down, okay. We can try to make this simple exercise. So what should we do? Well, we can start from this point, for instance, and follow all the dimensions to see how to do everything from one point to the other. Now there is a small mistake here, because you don't have proper references. I would say that this point here is aligned with this, because you have a 2 millimeters here and you have 2 millimeters here. This gap here is 1 millimeter, so this line is going to be 1 millimeter in X and 1 millimeter in Y. So I will skip between the two. Let's zoom in a bit, probably we need it, and let's start from this point. First line here, 2 millimeters, 2 millimeters. As we said, we have the positive numbers in this direction, so we have positive X and positive Y. You notice that in this case, this line is going both down and left. That means both quotes, both dimensions will be negative. So let's start relative to this point, -2, comma, -2. Okay, let's zoom in a bit more. The second one is 8 millimeters horizontal. This is easy. Relative 8, 0. Then we get to that line that we said before, that it's 1 because it's written here and 1 because it's written here. So this will be relative 1 on X and 1 on Y. 11 millimeters, 11, 0, this was easy. Then 1 millimeter down. Now I can actually write relative -0, because the first one is always the X, 0, -1, and I get where I want to. But this seems to be a good opportunity to introduce you to the smart track. Now, this is a pretty cool feature in Rhino. Must be used not all the time, because it could become annoying. But smart track is basically a way to highline a point just because you stay there a bit longer, or because you press Control, it turns off and on the point. When it's on, it creates lines that Rhino thinks could be relevant. Usually you have the vertical line and the horizontal line. This is 45 degrees. So when I go straight down up to this point, that's gonna be the position I want. When you press Shift, you see that when I press Shift, Rhino allows me to move only vertical or horizontal. So it's very easy for me to stay vertical and get to the intersection. Now, I didn't actually use the quote for this, the dimensions for this, but I'm pretty sure that the final result is good. I can't do the same though here, because I don't have the second dimension. So now let me show you something. This point is gonna be 6 by 2. If I do 6 by 2 right now, relative 6, 2, you see that it ends up in a completely different position. What do you think that this position is? Think a bit about it. So this position here is 6 by 2 millimeters, so 6 on X and 2 on Y, from the point that was highlighted when I was using the smart track. So if I'm in a situation like this, where I have a point that it's highlighted, the relative dimensions will be from that point. This could be very useful sometimes, and it can also be very annoying. So keep in mind, use the smart track when you want it and turn it off when you don't want it anymore. As you can see, you can turn it on and off even during the same function, the same lines or sketch, so it's pretty easy to use. So we said the second one is relative 6,2, and we get to the final point. Now this is just half of the arrow, of course, so I can search for the mirror function. My mirror plane will be between these 2 points, and these are my 2 halves of the arrow. Again, if I join it, it becomes a closed curve. That means that it matches perfectly here and here. That was pretty obvious because the line of the mirror plane was traced between those 2 points, but you never know. So this is a very simple example, a simple application of sketching with dimensions in Rhino. In your presentation, you have many more interesting exercises you can play with. So have fun, try some of this. Some could be tricky. The radius of this is relative to the centers that you can see here marked. If you have some troubles, don't worry. Here I added extra quote for you. It's not necessary, to be honest, but it's easier, makes your life much easier. So feel free to try. Let me see. You can also experiment in 3 dimensions. So if I take this curve and I extrude it, saying like I want it 10 millimeters, well, 10 millimeters is going to be too much, 3 millimeters thick. From this view, I don't see that much, but I can zoom this in every views and get my arrow. Now it's thicker than what I expected because I didn't notice when I extruded there was the function both sides active. I don't want it, so now it should be the right dimension. Okay, so you can try this. You can easily try this. You don't have the thickness of this object, but you can think about it like layers. So you will have a base, you will have 3 cylinders, and you will have an extra part here as well. These objects are probably different from what you're used to because they are more, let's say, technical parts. That could seem difficult for you, but these are the parts you need to laser cut or 3D print when you want to make some technical features and be sure and precise about what you're doing. Cool, that's it. I will introduce you the laser as well in the next video, and that should be it for today. Thank you guys.